Okay, I want to show you just how difficult or how time consuming the formula that I showed you before can be. So I just want you to imagine for a minute, I won't do this of course, that you had some homework where you had 400 values that look like this and you had to calculate the variance. And I want you to imagine what you're going to have to do. The first thing that you're going to have to do is put all 400 numbers in just so that you can get the mean. You'd have to do, that would take quite a bit just in itself, typing in 400 numbers and to get the mean for that. So let's say that the mean ends up being 1,003.91, for example. Then that's not all of it. Then remember, you're going to have to calculate those deviations and then you're going to have to square them. So you're going to have to do, for each value, you're going to have to take x minus x bar and then you're going to have to square it. So in other words, you're going to have to take this minus this, square it, and add on this minus this and square it, and add this minus this and square it, and you're going to have to do that 400 times. And then when you're done with all that and you've added all those deviations, you're going to divide by n minus 1 to get that variance. Okay? So hopefully you'll see after you've done a few by yourself that this formula can get quite complicated. Lucky for you, there is a shortcut. It looks more complicated, but it actually isn't. It's equivalent to this, but it doesn't even require that you know the mean. All you really have to do is you need to know what the values are, and then you're going to have to square each value, and then you'll be able to use this shortcut formula, which is convenient for messy kind of large data sets. Okay, it'll be much quicker to calculate. So this is really good for calculations. Okay, so let's use this formula together. We're going to square these values. We have 6 squared, which is 36, and then we have 7 squared, which is 49. So we're just squaring all the values. 81, 16. If you square 27, you'll get 729. And then we have 81 and 64. And the only other thing you need to do is add up the columns. So remember, if you add up this column, you are going to get the sum of the x's, which turns out to be 70. And here we're going to get the sum of the x's squared, because we've squared each individual value and then we're adding, and this is going to give you 1,056. And with those two values, you are going to be able to calculate the variance a little quicker than you did before. And so we're going to follow this formula right here. Okay, so here's the variance. This is the same accident data, so we should expect the same answer we got before. So what we're going to do first is we're going to get the sum of the x's squared. Notice that this is this column, the sum of this column right here, which is 1056. Then we're going to get this fraction, and notice up here, this is a little different. First, we're going to add the x's, and then we're going to square them. So we're going to take the sum of the x's, which is 70, and then we're going to square those values and divide by the number that we have. Remember that n is equal to 7 if you count how many values we have here. So this is going to be 7 over 7 minus 1. That is going to give you exactly the same numerator we had before, divide by 6, and you'll see this is a lot easier. And we got last time 59.3333. And remember, we also learned that for the variance has no units because these would be square accidents, which makes no sense. The standard deviation is found again by just taking the square root, which is 59.3333, et cetera, to get the accidents, which I believe was 7.7028 accidents. Okay. Now, what we haven't answered really is this a lot of variation or a little bit of variation? Is this standard deviation large? Well, Unfortunately, there's actually two things that are going into the size of the standard deviation. We know that if a standard deviation is 0, there's absolutely no variability and all the values are identical. So then everything goes up from there. So of course, more variation is going to give us a larger standard deviation, okay, which is what we expect. So the more variation you have, the larger the standard deviation is. But it also turns out that larger data values also are going to give a larger standard deviation. So in other words, these two components, so in other words, if these were 60, 70, 90, these were larger values, we'd get a larger value for the standard deviation. So there's two different things playing a role here. What we'd like to do to talk a little bit more about that is to eliminate the part that has the larger data values and only talk about variation. If you recall, in a previous example when we were comparing Mr. A and Mrs. B, remember their classrooms, and we wanted to know which class to take if we wanted a C, we could have compared the variation between those directly because they had the same mean. So those values were on the same scale, and so that was okay. What do we do when our numbers are, when we want to compare the variation between two or more data sets and the size of the numbers or the scale of the numbers is very different? We're going to need something called the coefficient of variation, okay? So what the coefficient does is for distributions having the same mean, we don't have to worry, okay? You can just go ahead and look at the standard deviations. The one with the highest standard deviation has the greatest relative spread in the sense that we're comparing the spread. So if two data sets have the same mean, the one that has the largest standard deviation has the more variation or the more relative spread. What the coefficient of variation does, and it's denoted by CV, it's used to measure the relative variation for distributions that have different means. So we're going to need the coefficient of variation when the distribution have different means. The actual formula for the coefficient of variation is this. We take the standard deviation and divide by the mean. I have put this here just to remind you that you need to convert this to a percent by multiplying by 100 and adding that percent. Okay, so when the coefficients of variation for two or more distributions are compared, the one with the highest CV is going to be the one that has the greatest relative variation. Okay, now it turns out that in finance, the CV measures the relative risk of a stock portfolio. So I want to explain before we go on with that, hopefully you understand that the higher the variation, the higher your standard deviation, the more risk you're going to have. So if, let's say you buy a stock, or even your bank account, whatever you want to look at, but if you buy a stock that always gives a 5% return, then there's really no risk involved. If you always get a 5% return, the standard deviation is going to be 0, and there's absolutely no risk involved. Now, if you buy a stock and 1 month it's 5%, and the next you lose 10%, and then you gain 12%, et cetera, the standard deviation is going to get higher and you're going to have more risk. Hopefully that makes sense. So the more variability, it's exactly what we saw with the teachers. There was more risk in taking the second teacher. Although you could get an A in that class, it was risky because you could also get an F. Whereas in Mr. A's class, everybody was getting a C, and so there's not a lot of risk involved there. So that is a key word that you should be looking for when dealing with the CV. Is this is going to measure when you're comparing the risk or the volatility of things. You would be using the coefficient of variation. So let's do an example. It says, assume portfolio A has a collection of stocks that average, so let me put that, they average a 12% return. We actually don't need the percentages because they're going to cancel. The mean is 12 with a standard deviation of 3. Okay, that's for portfolio A. Portfolio B, on the other hand, has a mean of 6% and a standard deviation of 2%. Okay, now if you look at these separately, it looks like A is probably a little bit more risky. Why? Because it has a higher standard deviation, but it also gives you a much bigger return. And we know that that riskier stocks are going to give us more, will give a better return in the long run. Okay? Now, so when you're looking at A and B, it looks like A is riskier, but you really shouldn't be comparing these because the means are different. And when the means are different, it means the scale of these values are different. So we should actually be calculating their coefficient of variation. We want to compute the CV values. Okay, so what I do is so that I can distinguish it, I usually write, I'm going to compute the CV for A, okay, and then I just put a parentheses and write down what I'm talking about. So to find the CV for A, what I'm going to do is I'm going to take that standard deviation, here you can see the formula, the standard deviation of 3, and I'm going to divide by 12, okay, and that is going to give me, oh, and remember you're going to multiply by 100 so that you can get a percent, and so that is going to give us 25% for this CV, okay? Then we're going to calculate the CV for the B portfolio. We're going to take the standard deviation of 2 and we're going to divide by 6 and multiply by 100, okay? And what you're going to get is 33.33%. You really want to make sure that your percentage is to at least 2 decimals because there is a big difference between 33% and 33.33%. So from this, you can see that even though, I'm going to even write this for you, even though portfolio B has a smaller standard deviation, oops, even though it has a smaller standard deviation or a lower standard deviation, let me write that down for you, standard deviation, you can see that from the CV, it's actually the riskier one. So it actually carries more risk than A. Okay, it actually carries more risk than A. So again, here you have a shortcut formula, and remember that when you're comparing the relative variation between 2 or more data sets, you can only do it directly if the means are equal. But if they are unequal, you must use this coefficient of variation to calculate the values. So you will practice this in your homework, both online and the homework that's included in this section.